If you begin with 25.4 milliliters of 0.249 molar hydrochloric acid solution and mix it with 24.2 milliliters of 0.226 molar sodium hydroxide solution, what is the final pH when they are mixed together? I've given you the balanced reaction there. And there's at least one similar problem in the lecture outlines, but let me go ahead and work this. It says, so we have a volume and a molarity over HCl, so we can find moles over HCl. We have a volume and a molarity over sodium hydroxide, so we can find moles over sodium hydroxide. Anytime you can find moles of both or two of the limiting reactants, this is a limiting reactant problem. And so limiting reactant problem means you have to do both sets of calculations and figure out which can make the smaller amounts. Any questions about that? If so, jump in anytime, but if not, then I'm going to go ahead and turn my milliliters of HCl into liters by moving my decimal point 3 places to get 0.0254 liters. Then the way that I solve it, which there are many ways to do it, you do not have to do it my way, but I set up a unit conversion factor where I take the molarity, I break molarity down into moles of HCl per liter. And then I get my liters to cancel out, and I find my moles of HCl. 0.0254 times 0.249. I get 6.32 times 10 to the minus third, or 0.00632. 632, yeah. So it's pretty close to how rounding up to 3, but it doesn't. So I'm going to keep 3 sig figs, 0.00632, and that's moles of HCl. I'm going to do the same thing for the sodium hydroxide. And when I do that, I get 0.00547. Moles of sodium hydroxide. Now, if this were a typical limiting reactant solution, I would then carry this calculation forward to see how many moles of one of my products I could make. And whichever was smaller, then I would know I have my limiting reactant. However, we're going to do a shortcut, or we're going to make an assumption here. For this particular reaction, all of the coefficients are 1s. Okay. And so that means if I have 0.00632 moles of HCl, and it's 1 to 1, I could make the same number of moles of either of the products, but let's say sodium chloride. If I had the same moles of sodium hydroxide as here, 0.00547, 1 to 1 mole ratios would tell me that I could make the same number of moles of sodium chloride. And so when all the coefficients are 1s, you can use the moles of reactant to tell you how many moles of product you can make. And so instead of going all the way to moles of product, what you can then do is use moles of reactant to determine your limiting reactant. And based on this, since my moles of sodium hydroxide are smaller, sodium hydroxide must be our limiting reactant. again, because looking at these numbers, we could see that these many moles of sodium hydroxide would make a smaller number of moles of sodium chloride than the moles of HCl. Are there any questions about that? Okay, so I'm not going to write that under here. I'm going to do some work under here in a minute. So over here, I'm going to write sodium hydroxide as limiting reactant. Because it is the smaller number of moles. And again, this is only true because all the coefficients are ones. This is a special type of limiting reactant problem. My next question, and I'll address it to everybody here. So if I have 0.00547 moles of sodium hydroxide, how many moles of HCl will it react with?
The same amount.
The same amount. Thank you very much. So my next step is to say that 0.00547 moles equals my 0.00547 moles of HCl reacted away. And again, that's because it's one-to-one stoichiometry. And when we work limiting reactant problems, we always go back to the limiting reactant, which in this case is the sodium hydroxide, and do stoichiometry to find out, in this case, how many moles of HCl react. And the number's exactly the same. All right, so remember, I just want to touch base with what we're trying to find. What is the final pH when they are mixed together? We have a couple pieces of evidence, a couple things we can say already about this. So first off, because our sodium hydroxide is our limiting reactant and we have excess hydrochloric acid, we know that the solution will be an acid solution, and so the pH will be less than 7. Further, that if we're going to determine the pH for this solution, we need to find the moles of HCl that are left over. We know the moles of HCl that we start with. We know the moles of hydrochloric acid, HCl, that are reacted away. So the next thing we're going to do is find the moles of HCl left over, which is going to be just subtracted. And I'll write it out specifically for this. So our moles of HCl at this, to start with, minus our moles of HCl reacted away. The difference is going to be the moles of HCl left over, 0.00632 minus 0.00547, 0.00085. And those are going to be moles of HCl left over. Now, there's a couple other things we have to do in order to get to pH. We need to find the concentration of our HCl, where I'm using square brackets to tell me that I'm talking about concentration. Our concentration of HCl is going to be our moles of HCl left over divided by our total volume. And then our moles of HCl left over we just calculated. And our total volume is going to be our volume of our base plus our volume of our acid. For this particular one, 0.0254 plus 0.0242. I get 0.0496 liters. And my concentration of my HCl, 0.00085 minus 0.0496. Whoop, 0.00085. Let's try it divided by 0.0496. 0.0171 molar HCl solution. And from here, I know we still haven't gotten to pH, and this has been a very long problem, and we will work a number of these. So from here, we would say the following two things. Since HCl is a strong acid, it breaks down 100% into H pluses and Cl minuses, which tells me that my concentration of H plus is 0.0171 molarity, the same number. Are there any questions about that, making this into my H plus or my hydrogen ion concentration? Because we can only do this for strong acids, and HCl is definitely a strong acid. And I can only ever ask you the pH of strong acid solutions or strong base solutions, by the way, but this is a strong acid. Nothing weak. Okay, then my final step is if I know my concentration of H plus, my pH is the negative log of this concentration. And for mine, let's see, I have to enter in 0.0171 and then hit my log button here, and I get minus 1.767 or minus 1.77, and then when I take away the minus sign, I get 1.77 as my pH. And that is definitely less than 7. We said that this is an acidic solution, so pH should be less than 7, and good news, it is.
Professor?